gavel. Yeah. I don't think it does anything other than hurts his ear. All right. I had a couple of good questions during the break, and I just wanted to share with y'all. Had a couple of good questions. Thanks, Corey. I can't do that, so not a look. I had a couple of good questions during the break. The main one I wanted to share with y'all was cost on bioretention cells. We usually figure $10 to $12 per square foot of surface area installed. So it depends, and you can see the one I just showed you, the Lewisburg cell. The initial cost was $10.25. That was what was bid at. That was what the cost was when it was bid. And then with change orders, we came in at slightly over 13, so that's more than we'd like to see, honestly. But $10 to $12 is what I figure for rough design estimates when I'm going in to put a cell in. Question?
At what depth?
Typically 3-foot media depth. So you're going to have 5 foot of excavation, 1 foot for the bowl, typically about 1 foot for the gravel drainage layer, and then 3 feet for media. Yep.
Can you repeat that? I didn't hear.
$10 to $12 a square foot, and then that's with a 3-foot media depth.
3 foot depth.
Typical 3-foot media depth. That media is expensive. It's like $25 to $30 a yard, and then you got to pay for delivery as well.
What's the surface area?
Well, it depends on what your surface area is. What we usually figure for design is $10 to $12 per square foot of surface area of the bioretention cell. So if you have a 1,000 square foot bioretention cell, you can figure, $10,000 to $12,000. Does that make sense? Yeah. Question? Maintenance costs. I have some estimates from City of Seattle, and I think they figure $1 per, or 75 cents per square foot per year, I want to say. 75 cents to $1 per square foot per year.
75 cents?
To $1 per square foot per year. So if you got a 1,000 square foot cell, that would be $1,000 per year. Question?
For a source of this media, do you go to a concrete plant, say 70-85% sand?
Yeah, it's a good question. We have, I think, and Chris, maybe you can correct me if I'm wrong if you know of more, but I think I know of about a handful of sand pits that can get this mix correct in North Carolina. And the mix has been around for 8 or 10 years, so there's not a lot of people that sell it. There's a couple near Charlotte, I think one near Winston-Salem, one near Asheville, one near Raleigh, and that's it that I know of. It's hard to find. It's basically word of mouth with people that sell it. It's typically a sand pit, and then they'll take clay and mix it in. They've typically got like an 18-wheeler that's got 3 hoppers in it, and they'll put sand in one, clay and silt in one, and organic matter in the third. And then the one that I've seen, it's all computerized. He dials in what he wants percentage-wise, and it shoots it off the conveyor into a large pile, and that's what they use for the media.
So they don't use stone in it?
No, there's no stone in the media. There's stone in the drainage layer, but not in the media itself. Question?
How can you verify during construction that first truckload is correct?
Yeah, it basically should feel very, very, it's a feel thing more than anything else. It should feel very, very sandy, but with a little bit of clay, so you won't be able to ribbon it like you would a clay, out to this, but you can get a little tiny bit of ribboning on it typically. Other than taking a soil test and going and doing a particle size distribution, that's going to be your best bet.
The geotechnical engineer be able to...
They would be able to do a particle size distribution. Yes, correct. Yep. Any other questions while I'm bringing up the permeable pavement talk?
Maybe at your next time you could bring samples of that.
Sure.
Because I've been in permeable workshops, and you can tell that's half the thing is just by seeing what it's.
Yeah. What it looks like.
So
Yeah.
if you have 100% sand in the media, what fall off in performance would you have?
A lot of the performance is due to especially for metals and phosphorus, the adsorption that's occurring, or the chemical binding of the phosphorus and metals to the media occurs to those clay and silt fraction. There's not much adsorption that occurs because of cation exchange capacity, for those of y'all who know soils. If you don't have clay and silt, you have a very low cation exchange capacity, and therefore you get very little binding of, it's basically cation bridging that's occurring. Those of you who have taken soil chemistry, if you haven't, don't worry about it.
Mostly the metals that would be an issue.
Metals and phosphorus, those are the two that are going to be.
Other than that, performance.
TSS is going to be the same either way. Yep. I mean, the performance is going to be better than a sand filter because you do have that clay fraction, and you've also got the organic matter from the mulch and the organic matter that's in the media. So those are the things that are going to drive better performance.
Have you tested plant material as to the absorption? Because I know that some people had years ago.
We haven't. It's been hard. We just had a hard time getting grants to do that. We tried last year. The main work that's been done on plants is out of Australia, and obviously their plants are very, very different from what we have here, so it's hard to compare. Yeah. All right, let's talk permeable pavement, performance and maintenance, and I'm also going to give you a case study for construction as well. What is this? Mediterranean Basin. What specifically in the Mediterranean Basin? Roman Empire. Very good. What did they say about the Roman Empire? All roads lead to Rome, right? They were great road builders, and this was their typical design, 23-foot width. This is very similar to what we'd have for a 2-lane road, right? Drainage ditch on the side, an aggregate foundation layer, a supporting layer, and then the rocks on the surface. And these obviously have lasted very well because you can still walk on them, right? The Appian Way, etc. So we kind of borrow from this a little bit in permeable pavement design because we have open graded aggregate underlying our surface pavement course, which of course is porous to allow the water to move through it. So what types of permeable pavement out there? You'll hear pervious pavement, porous pavement, permeable pavement. It's all the same, one and the same in my opinion. PICP, I'll throw that term around a lot. Permeable interlocking concrete pavers. These are what you see here. There's a number of different designs of them, but they have chamfers on the blocks themselves to help the pavers interlock and provide you better structure. And you can contrast that with the concrete grid pavers, which have been around, I think, for, 20 years at least. These are used for driveways a lot, and they don't interlock. You can see they just abut each other. So you tend to get more rocking structurally over time, and so we don't really recommend them for use. Actually, we don't recommend them for use in North Carolina for permeable pavement. Here's another example of PICP. This is at the Old Woman Creek National Estuarine Research Reserve near Sandusky, Ohio, where I'm doing some work up there, and you can see they've done some very nice picturesque PICP, so you can spend as much money as you want, of course, on any product. The other two big ones that are out there, pervious concrete and pervious asphalt, they look something like this. So there's roughly 20% void space in a typical pervious asphalt or pervious concrete installation. They're installed very similarly, well, I want to say very similarly. They're installed in a similar fashion to typical concrete or asphalt pavements. The mix design is very different though. You're typically taking a lot of the small silt and clay fraction that's in a typical concrete or asphalt mix and removing that almost entirely. You have much larger aggregate, especially in the pervious concrete. So here's an example. This is up in Pennsylvania. I took this picture. This is in Philadelphia. You know, they're spending, I think, $10 billion on green infrastructure up there. It's some really large number. You can see pervious concrete here on the right and pervious asphalt here on the left. So what do you note about that picture? Got some runoff on the left, right? There's some runoff on the porous asphalt. The concrete looks pretty good. So what do you think went wrong here? What happened? A couple options. Too much binder. Too much compaction. So you're saying that it was either installation or mix related. Or it could also be clogging, right? Those are really the three options. And or somebody's gasoline. Yeah. I promise this was water. I watched it occur. And so in this case, this had to do with a binder issue and the binder actually melting in the porous asphalt. And this is something that we've run into a lot in North Carolina. You do have to be very careful with the mix that you use, especially with porous asphalt. The typical binder that they'll use is 64 minus 22. And what that means is the binder is okay between 64 degrees C and negative 22 degrees C. Okay, 64 degrees C, off the top of my head, I think that's like 125 degrees Fahrenheit. And if you've walked on asphalt pavement in Atlanta in August, it gets to a lot more than 100, barefoot, it gets to a lot more than 125, right? So what happens is that binder will melt and you will get very expensive impermeable asphalt, which is not a good thing. So there are things you can do with the asphalt design. I'm not going to talk about this because I just didn't have time to do it extensively, but there are other binders that are out there. There's 7622, which is good between 76C and minus 22, and there's also 88 minus 22. Those binders obviously will give you better performance at higher and higher temperatures. They are more costly. It will make the mix much stiffer and harder to work with when you're putting it down. You can also insert basically polymeric fibers into the mix as it's wet, mix that in, and that will give a greater rigidity to the pavement as well. and prevent the binder from melting. Obviously, all of those additions, every one of those additions adds to the cost. And so while porous asphalt is the cheapest, when you look at it side by side, you can usually get porous asphalt for $4 to $6 a square foot. It's my gut feeling on it. When you start adding the more expensive binder, the polymeric fibers, it starts to get very similar in cost to porous concrete, permeable concrete, which is typically 8 to 10 roughly, and then PICP is going to be 10 to 14. It's the most expensive out of the group. Okay, last type of permeable pavement that's out there are these plastic reinforcing grids. Have y'all seen these before? Kind of a cheaper option. This is what happens to them 10 years later. This is again at Oldham Creek. We're about to rip this up and put porous asphalt in instead and monitor it. This is up near Sandusky. You can see the plastic grids have sort of photodegraded. They have structural issues. Of course, this site has heavy clay. It's hydrologic soil group D. That gets drug in on tires, and so this becomes impermeable, very close to impermeable very quickly. So this does see, this is parking spaces, yep. And so we do not recommend these in North Carolina. They are plastic reinforcing grids, is what's typically the term for them.
What about temporary things? Like I've seen them like for fire truck
Yeah.
things where they want to have grass and.
Yeah, I think they're fine for infrequent use. This particular application gets parked on nearly every day, and so that's a real challenge for them.
Our e-toy facility, I don't know if anybody has been out there recently to see if it's holding up all right, but it's the same type of application. Anybody here from this?
So this happens to be the mall in the town I live in Cary, which if y'all probably aren't familiar with the acronym, but happens to be an area where there's a lot of Yankees. And we're in the south, of course, so they call it the Containment Area for Relocated Yankees. That's the acronym. That's the acronym for Cary. I'm not a Yankee, I'm from Florida originally, so one of the few people that was born in Florida. Anyway, this is the mall in the town I live in. And you can see the amount of parking and how well I took this picture maybe 5 or 6 years back, and you can see how well utilized it is, right? Very little parking. There's way too much parking except for Black Friday and whatever. So I would argue we're over-designing our parking lots, right? Especially those outer areas of the parking lot for perhaps the 100-year shopping event, right? So perhaps these are areas where we can use pervious pavement to get stormwater treatment out of our large parking lot. So here's a typical pavement cross-section. In this case, there's pavers on the surface, but this could be asphalt or concrete. You typically have, it's an open graded base layer of rock, so washed rock that of course has porosity to it, so that can store water, and then the water then infiltrates into the underlying soil or goes out an underdrain, very similar to what you might have in bioretention. Typical applications, pedestrian, so this is down at the beach. You'll see a lot of concrete grid pavers down at the beach in North Carolina. What's the issue with these? Other than tripping, right? As an engineer, what do we care about? Health, welfare, and safety. And so that's an issue, right? Tripping hazard. This is an example of the turf reinforcing grids with fire access. We put in this bioretention cell, and the town wanted fire access to the bioretention cell, which... So anyway, there's turf reinforcing grids under here. Don't get me started. I'm not going to name the town either. I refuse to do that. Another one of my dream homes, this happens to be a really expensive neighborhood where most of the Carolina Hurricanes live, the hockey team. So this is probably some Russian or Swedish guy who lives at this house. Street side applications, we see a lot of these. Street side permeable pavement, this works really well because you're treating some of the asphalt will run onto this. You'll treat some runoff. The maximum runoff ratio that we allow in North Carolina is 1 to 1. So 1 part impermeable to 1 part permeable. That's actually relatively low. There are some states like Ohio is 5 to 1. Texas, I believe, is 2 to 1. So there are other states that have taken that runoff ratio to a much higher extent. This is a retrofit that we did down in Wilmington. In our coastal city, you can see it's parallel parking stalls along a residential street, and we've basically used these baffles to direct water from the curb line onto the permeable pavement so the water will infiltrate. If you're doing this as a new construction, you can just simply change your gutter cross-section such that instead of angling towards the curb, it angles out towards the permeable pavement, and you'll get that without having to put the baffles in. Does that make sense?
Do you wrap those cells in geotextile or not?
This one, no. So these are concrete barriers right here. Concrete, and I'll talk about these a little bit more, but these are concrete, basically 12-inch deep concrete edge restraints. Thank you. Appreciate that. So that's going to lock the pavers into place, but the other thing it does is it separates the underlying structural layers of your asphalt, standard asphalt right here, from the aggregate underlying your permeable pavement.
You can't get that drainage.
Because what you don't want to have happen is have water seep from this permeable pavement underneath your asphalt, because that will cause structural issues. So this concrete barrier is 12 inches deep, and the typical cross-section of this particular street was like 3 inches of asphalt and then 6 inches of ABC, I think. So it's only 9 inches deep, so you're separating the two hydraulically, which is what you want to do. You could also use a plastic liner, but in this case the concrete helps to separate the asphalt, which is a non-rigid pavement from the permeable pavement. And it also, again, helps to lock the permeable pavers into place. Parking lots are another place you'll see them. This one's in Wrightsville Beach in North Carolina, PICP application, and then Pervious concrete. This is at a park in Wilmington that we designed some years ago. It's about 10 years old now. PICP, this is again New Zealand, and tree pit combination. So this is a tree pit here, sort of like a bioretention tree filter, if you will, with Pervious pavement there. And you can see that you do have to have aggregate. This is PICP here. You do have to have aggregate between each of the blocks in order to allow for water to move, because the blocks themselves are not pervious. They're impermeable. It's the interstitial spaces that allow water to move through. It's a good question. We're doing actually some tree research right now. It's kind of branching out, if you will. Sorry for the pun. Horrible. My gut feeling is it would probably be okay, but it's just a gut feeling. I don't really have any data to show, because the worry obviously would be that it would disturb the aggregate, the roots would, and then you would get heaving of the pavement, and your pavement would have differential sort of settling in it, if you will. I would probably put a root barrier in just to be safe. I'd like to say yes, though. Okay, low-speed roads. Note the low speed. Less than 25, 30 miles per hour. Above that, where you have substantial amounts of braking, you're going to get very quick structural failure of your pavement. The one exception to that is DOTs across the country will use what's called a permeable friction course, or PFC. It's a 2-inch pervious asphalt overlay on a highway, so like I-75, I-85 here in Atlanta. It has a standard asphalt cross-section underneath that pervious asphalt surface course, and so what it does is it drains the pavement, so it's permeable, obviously, so the water drains quickly, so you get less hydroplaning, you get less spray and splash, you get all those benefits, and there's also water quality benefits that we've proven as well, us and Mike Barrett from University of Texas at Austin. But if you're doing a full-depth permeable pavement, you want low-speed roads, low speed.
Along that same line is a concern, and we discovered this in City Plan, is that where you have traffic lights
Yep.
and buses putting on brakes,
Yep.
accelerating.
You want, PFC is really an interstate highway BMP, and that's it. You want no stoplights, no stop signs, as little braking as possible. You want high speed, 55 miles per hour and greater. But for full depth permeable pavements, you really want low speed residential roads. So this is an example of permeable concrete. And then again, PICP road here in Kapiti Coast in New Zealand, a residential street there. And there's Elizabeth Fassman. She's the professor down there that we work a lot with. So thanks to her. The Green Alleys program, this is pretty famous.
Be okay for buses and also for occasional tractor-trailer loads?
So I'll talk a little bit about structural design, a little bit, because you could spend an hour on it. You can design these systems for extremely heavy loads, extremely heavy. They're used at ports around the world, but they have like 4 feet of aggregate underneath the pavement. So it's flexible pavement design. For those of y'all who are civil engineers, all it is flexible pavement design. Structural numbers, layer coefficients, standard flexible pavement design. So you can put any load on these you want to. You just end up with feet and feet and feet of aggregate, and of course that's very expensive. So
The problem with the bus is not the load.
It's the stopping.
Acceleration and stopping.
Yeah, yeah, I agree with you.
Plus stop.
I agree with you. Yep, yep. Well, and the load can be a problem too if you don't design the cross section correctly. Yep. Green alleys. So where does it work, or how does it work? Again, a cross section here. We had a failure, so I got to take this nice cross section, which was kind of useful. So under drain, and then there's a base course, which is typically like railroad ballast size, so like what you see on a railroad bed. And then a course above that is typically 57 stone, and then the bedding course, in this case, would be 78 stone. You can use various sizes of rock, though. Like if you do permeable concrete, they'll typically just do a 57 stone cross section across the whole without having any changes in gradation, like you do with PICP. So how deep does gravel need to be? There's two functions. One is hydrologic, so how much water are we storing in the porosity of the rock, and the other is how do we hold up the pavement, right? It has to be structural. So those are your two design considerations when you're designing a permeable pavement. So structural calculation is very similar to structural calculation you do for any roadway. It's based basically on your 18 kip vehicles, your very heavy loads. How many delivery trucks are you getting? How many 18-wheelers are you having pass over that permeable pavement? So for instance, like a loading dock, here this permeable pavement would have to have a lot more structure underneath it than a typical like residential road would. And then there's also structural support provided by the underlying soil, so California bearing ratio. If this is Greek, don't worry about it. But for those of your engineers, California bearing ratio, and then also